So yeah, as you said, we're going to talk about hybrid mobile apps, Cordova apps in particular. First, I'm going to introduce what are hybrid mobile apps. I'll show you what we found in the Google Play Store when we searched for them. I'll also tell you why they are terribly insecure, and Achim will later tell you how you can still develop a rather decently secure hybrid app. So first of all, what is a hybrid mobile app? So traditionally, you have two approaches to mobile app development. On the one hand side, you can decide to develop a native app written in Java, Swift, or C#, depending on the platform that you're targeting. With these kind of apps, you usually have all features available that the platform provides you, such as GPS or camera access. But they are very platform specific. So if you want to target multiple platforms, you usually have to redevelop all of them. On the other hand, you can decide to develop a web app written in HTML5 and JavaScript. They are hosted on a remote server. You can target all platforms at once with them, but they're usually rather limited in what you can do on the device, since they are usually confined to the browser window. But the advantage is, yeah, they're quite platform independent. So in order to combine the best out of these two worlds, people came up with the concept of a hybrid app, where you mix the native part with the web part, HTML5 and JavaScript. And the idea is that you can build them once and then run them on all these platforms, compile them for all these platforms into sort of native apps. And you get the access to the device-specific features back by using so-called plugins. So this is the general architecture of an Apache Cordova app. So the main part of the app is basically this box here. You write it in HTML5 and JavaScript. That's where your application logic goes. And it all sits in an Android web view, which then, by using Android or Cordova APIs, you can communicate with the Android platform or with your plugins that allow you then to gain access to these platform-specific features. Cordova provides an implementation of these plugins for all supported platforms, and you can just then use your JavaScript API to make use of them by using these plugins. So let's shortly introduce a quick running example of a small hybrid app that we're going to use. So this is a very simple app. It just gives you one window where you can search for a contact name. The app will then look up the phone number from your local contact book. And I don't know if you can read it, but simply display the telephone number it found in the telephone book. So I'm not sure how much you can actually read, but this is sort of the main part of the hybrid app that you just saw. So on the top, we have the JavaScript part in blue. On the bottom, the Java part. You have a small function on the JavaScript side where you start, show phone number. On the JavaScript, and on the Java side, on the bottom, you have one Java class that basically is the plugin that is used to access the local contact book. So the main part of this hybrid framework is the so-called exec or execute method that is provided by the Cordova framework. And this is the main method that allows you to actually communicate between the Java and the JavaScript part of your app. And yeah, you call it from the JavaScript side, and as usual in JavaScript, you get your result in the form of callbacks. Now, example, you have a success callback that, when it has finally retrieved the telephone number, it simply presents it to the user in an alert box. You, on the JavaScript side, also specify where you, basically the target of your call, which is a string here and corresponds to the name of the Java class. So that translation is done by the Cordova framework. Similarly, you have an action that you specify. In our case, find. We want to find the telephone number. And it also corresponds to a method on the Java side. And then finally, you have an argument, in our case, the contact name, that you see on the Java side goes into a simple SQL query that finally retrieves the telephone number. And yeah, the Java side extends the class Cordova plugin, so it can provide this feature by implementing the execute method. So we call this framework, or the core of the framework is called Apache Cordova, but it actually has many different names. So many companies like SAP, for example, they went ahead and provide a bunch of advanced plugins. So you will find Apache Cordova under the hood of Adobe PhoneGap, for example, or SAP Capsule, which is basically Cordova plus a bunch of proprietary plugins that are also provided for features that you would need for an SAP app, like some secure single sign-on or so. So we also had a look at, we wanted to find out what kind of Cordova apps people actually write and what we can find in the store, how people use this framework in the real world. And yeah, the first thing we noticed is that especially the rather security critical areas like business, finance, or medical, they make rather heavy use of this sort of hybrid application. And on average in the store, there are about 5–6% of Cordova apps. So we had a more closer look at the top 1,000 apps in the Google Play Store, and we found that around 10% of these apps ship parts that we identified to be part of the Cordova plugin, of the Cordova framework. But we also finally noticed that only half of these actually make use of Cordova. So quite some of these apps, they ship plugins or other parts of this framework, but don't actually use it. Maybe because it ships as part of another library they use, we don't know. And we also had a closer look at 3 apps from SAP that use the SAP Capsule version of Cordova. And we also developed a small static analysis tool that analyzes these Android apps in the form of the APK files. And we wanted to put our focus on this JavaScript bridge and wanted to find out how many of these apps actually make use of this bridge. Are they just static websites, or do they actually want to communicate with the Java platform side of this framework? And we also wanted to find out what kind of plugins do they use, how critical are they, since the plugin is where this cross JavaScript Java communication is actually being done. So we learned that, plugins are used for a variety of different things, but most of them were rather simple. So more than half of the Cordova apps we found use the device or in-app browser plugin, which just provides more information as to on what kind of device the app is running, which a little bit defeats the platform independent purpose, I guess, if you then query on what kind of device they're running anyways. But yeah, we also saw plugins that provide access to the file system or the camera. We were also surprised to see that many of these Cordova apps are really big, especially the 3 ones from SAP that we had a closer look at. They actually had more than 300,000 lines of JavaScript in the second app, for example, and also quite a lot of Java. And that is in a rather small mobile application, which is probably due to the large amount of libraries that they probably just include, because they just use the stack that they usually use for the normal websites. They also use that to start with their Cordova applications. And we noticed that there's quite an asymmetry between the cross-language calls that are being used. So we found only very few calls that go from JavaScript to Java, and way more occurrences of Java code that actually calls JavaScript functions, which we found a bit weird. And yeah, we also noticed that, as I said already, that some of these apps, they ship the whole Cordova framework but don't use it, which is weird and opens up definitely some security questions. And we also found plugins that make heavy use of the Java native interface. So this is this interface on the Java side that allows you to call functions from compiled C libraries. So we actually found one Cordova app that, besides the JavaScript and Java part, also ships a small library written in C that provides some basic arithmetic functions, where we really were asking, is that really necessary to even include 3 languages in this one rather simple app? Yeah, now I wanna put the focus a bit more on the security side of Cordova apps and the ones that we found. So why is the security of these hybrid mobile apps so hard? Well, first of all, you have the JavaScript side of your app. There you have the normal challenges that you face with your typical JavaScript application. You don't have typing, you have higher order functions, a very asynchronous programming model, which is rather different from your regular Java programming. And yeah, JavaScript is highly dynamic, provides nice functions like eval. And usually you have big JavaScript libraries, not just on the JavaScript side, also on the Java side, that make your whole project even larger and more complex, in addition to a complex framework such as Apache Cordova. And yeah, on top of the challenges of these both worlds, you also have the additional challenge of the question as how do these data types, for example, convert? As we saw earlier, we have this central function execute that allows you to call a Java function from the JavaScript code. And yeah, what happens, for example, if you just dump in a JavaScript object? What comes really out on the Java side? So to come back to our running example, the small get phone number application, I wanted to visualize a little bit how the data flow in such a hybrid app looks like. So we have the JavaScript side of the app on the left side, the Java part on the right side. And it starts with a query of retrieving the phone number by passing the contact name from the JavaScript to the Java side. Then it gets looked up in a local database, in the contact database. And then we pass the found telephone number back to the JavaScript side of things. So here in this one example already, we traversed this language barrier 2 times. And that already raises a couple of questions. So are we actually already concerned on the JavaScript side about a possible SQL injection? Do we already care about the SQL, sanitizing our SQL string there? Or on the Java side, when you query the database, you're usually not already concerned about the possible cross-site scripting attack. So this adds quite a bit to the level of complexity here. So yeah, we found that this JavaScript and Java bridge is actually the main focus of the security analysis of a hybrid app. And this is not only due to weaknesses that can be found in the Cordova framework itself, such as this one here from a few years ago. So on the Java side of things, you can expose a Java object to the JavaScript side by calling a function called add_JavaScript_interface. So you see in the first line, the Java developer exposes a file utils object to the JavaScript side, which can then be used as follows on the JavaScript side. As you can see in line 3, there's something written to a file. But what the developer probably didn't anticipate is that you can also use this exposed function to call some Java reflective functions on it, which the JavaScript developer is usually not really concerned with. So yeah, here the vulnerability was that this add JavaScript interface function exposed many more Java functions than it should have done or as was specified. So after that, they introduced a Java annotation that makes it very explicit which functions get exposed to the JavaScript side and which one aren't. But it can get even worse. So assume you have a very simple hybrid app on your device, and you want to include the small advertisement iframe. We have our regular app, and we fetch the ad from the internet and an iframe. So the index HTML is local, but we fetch the advertisement from the internet. Especially, it's especially bad if you don't secure it over SSL, since an attacker can simply intercept your call and provide you with a different JavaScript function. Well, that is business as usual if you don't encrypt your traffic properly. But what can now happen in the case of a Cordova application is that since you have these two bridges that bridge the functionality between your Java and JavaScript side, this evil.js script gets suddenly much more powerful. So it doesn't just infect your JavaScript side. So because Cordova exposes such a frame, such a bridge in every iframe and every website of your app, even a simple add iframe has suddenly this big access to all your Java functionality, all your plugins that you included, which is definitely not what you would expect from an iframe. So as the regular web developer, yeah, you would say an iframe is pretty sandboxed, but in this case, Cordova goes along and also exposes this JavaScript bridge. Oh, now Achim will tell you how to make things at least a little bit more secure.
Okay, up to now we've seen quite a couple of security challenges that we have in mobile apps. So let's see if the world is really that bad. Actually, it is not. What we have to keep in mind is that a Cordova app foremost is a web application. So usually, as a standard developer of a hybrid application, be it Cordova or one of the other hybrid frameworks, you are mostly developing a web application. So whatever we learn from secure programming in terms of web applications needs to be applied here as well. That's one of the challenges. If you're doing mobile web development or hybrid development, you need to be an expert in web application security, do your secure JavaScript programming, be aware what is the meaning of content security policy, same origin policy. Keep in mind that some things might be a little bit different, like the iframes, what Michael just motivated. So the sandbox provided by the web views on Android, and I guess it's the same on iOS, are not as strong as we have it on modern web browsers. And also usually the web browsers on the desktop are developing much faster in terms of security than the ones on mobile. Then on the other hand, Cordova apps or hybrid apps are native apps. In our case, we mainly looked at the Google Android applications. The native part is written in Java. So here again, as a developer, you have to apply all your complete knowledge about secure programming in the language used for the native part, be it Java, be it Objective-C, or be it C#, for example, for Windows Mobile. Clearly, whatever is coming from the JavaScript world shouldn't be trusted. So whatever comes from the JavaScript world, even so it's your application that you are writing, you shouldn't trust it and do a second defense validation within the native plugins to secure your application. Then, of course, hybrid applications are applications using a specific hybrid framework, such as Cordova. There are additional security mechanisms and documentations that you need to take care of. So, for example, whitelisting of plugins, so specifying which plugins within the Cordova framework are actually allowed in your application. And Cordova itself provides quite a number of additional security mechanisms that you should check as well. So besides, you need to be an expert in web application programming or secure web programming and secure Java, Objective-C, C# programming. You need to be an expert in the framework that you are using. And then finally, we are talking about mobile apps. So whatever security mechanisms your mobile operating system provides needs to be taken into account as well, like the permission system of Android. Then clearly, if you're working on mobile, it's always a good recommendation to consider which versions you actually want to support. And if you are able, without losing your customer base or the majority of your customer base, to stop supporting very old and outdated versions of the mobile operation system, that's usually something good with respect to security. If you decide to outphase support for old versions of your mobile operating system, take that opportunity to refactor your source code and remove no longer needed implementations, for example, for a custom key store, because in the meantime, all the major mobile operation systems are providing an own key store. So there's no need anymore for implementing own key stores. Then clearly validate all the SSL certificates. That's I guess yearly, weekly, monthly horror story that mobile applications are not validating SSL certificates. And as a security guy, I'm asking myself often, why does this actually happen? Validating SSL certificates shouldn't be too difficult. As a developer, I know that many of the APIs being used for validating SSL certificates are not as user or developer friendly as they should be. And even more, in the meantime, it's registered as a bug in the Cordova bug tracker. But it's most likely a bug that will not be closed because there's a heavy debate on it if this is a bug or a feature. And if you read closely here, the bug report reads, right now, when you create a debuggable Cordova build, that's, by the way, the default behavior if you are building Cordova applications on the command line, like using the Cordova run Android mode, for example, all HTTPS certificates errors are ignored silently. That means as soon as you ship accidentally or by conscious decision, and Cordova app with the debug flag in the configuration set to true, all your SSL certificates will not be validated, even if you have implemented correctly all the SSL certificate checks. So that's really kind of a correlation between two options, wanting to debug an application and wanting to disable for certain testing purposes the SSL checks, which are now in one configuration flag, which is really not intuitive. And I guess not many people developing Cordova applications are actually aware of that behavior. So keep these kind of strange behaviors in mind as well. If you want to look up the whole bug report, you will see that people are discussing, and the final conclusion at the moment is that most likely, I don't believe that it will be fixed or changed, the behavior, because it seems to be technically difficult for the Cordova people to change that. Even so, from a security perspective, I would consider that close to being a disaster in terms of usability for developers. And that's clearly a sign where we make it very hard for people to develop applications that are secure by default without any good reason for doing so. We have seen there are vulnerabilities in the frameworks as well, and actually those frameworks that allow you to program your application in many different technologies are usually rather complex. And complex software, as we all know, tends to have bugs as well and vulnerabilities. So there's the clear recommendation that you should use the latest version of the various frameworks that you are using. That's a general, in our experience, a good recommendation in terms of using third-party library. As Cordova is an open source project, an open source framework, you most likely need to monitor vulnerabilities yourself. Most likely, if you're using pure Cordova, you don't have a support contract where a vendor is notifying you about vulnerabilities. So one way, for example, is looking the CVE database and then acting accordingly when vulnerabilities are being published for the version of Cordova that you are currently consuming. I hope also that if you are doing secure development, you are using some form of security testing in your SDLC. For example, static analysis, which is kind of the workhorse of a secure programming practice, a tool that statically analyzes, so without executing the source code of programs, and computes a kind of heat map showing developers which are areas that are potentially insecure. There are a lot of different tools available. I'm not talking here about one specific tool. Just as a general consideration, if you have these kind of hybrid frameworks, usually your static analysis tool, while it can analyze, or many of them can analyze various languages, they will not connect components written in different languages and analyze data flows between them. In principle, there are three ways for analyzing these kind of hybrid apps if we would have an ideal static analysis tool. The one would be, let the tool run over the whole framework source code and learn how that framework connects the different components of your program. That would be cool if we would have such a program, because we wouldn't need to configure anything, in which with each new version of Cordova or a different framework, we would rerun the static analysis tool, train it, so to speak, and we would be settled. Sadly, that seems to be unlikely that we get such a tool in the near future. The other alternative would be modeling the framework. That means you need to model how the framework connects the various parts of your application, and then insert the data flows in that. That's something which we actually can expect tool vendors to do. And our research prototype shows that this is actually a very effective way of handling that problem, because it has the big advantage that you only have to adapt your static analysis tool once for the Cordova platform, and it automatically works for all plugins being provided, also for newly written plugins or for modifications that you might want to do. And the third way, that's kind of the solution if you cannot analyze or analyze both languages and bring the results together, is modeling the plugins, the interfaces, so that you can run a static analysis in both language parts and just decide in terms of the interfaces if the data flows are secure or insecure. So let's have a closer look on that, or my recommendation on that, our recommendation on that is, in case you are developing hybrid applications and are using a static analysis tool, and you find yourself that you rarely ever develop plugins, you're mostly developing HTML5 JavaScript, great. I hope you have a static analysis tool that works well with JavaScript and supports you in that. Please ensure that your static analysis tool then knows the APIs of the various Cordova plugins that you use, so that it can really do a proper data flow analysis in terms of knowing what are the dangerous sinks and sources are that where data either enters the native side of the Cordova framework or is received from the native side of the Cordova framework. And if you're working together with a commercial SaaS tool vendor, talk to the support guys of that vendor if they support the plugins of Cordova that you are actually mostly using in your development. If you're on the other side, mostly developing plugins, then you can do the same approach only on the Java or on the native side. So hopefully you have a nicely working static analysis tool for your native language like Java. Again, ensure that the plugin APIs interfaces are configured so that you have the knowledge, or that the tool has the knowledge about the insecure sources and sinks where data is received from the JavaScript world. If you're really developing Cordova apps in both sides, then there are in principle two ways of doing that. If you have a tool that works nicely for JavaScript, another tool that works nicely for Java, then you can just combine the two approaches I just discussed, using the tools, scanning the source code in isolation, but again, ensure that the APIs for the plugins are actually configured. If you're in the lucky situation that you have a tool which can scan Java and JavaScript very well, and where you can insert custom data flows, then it's actually a recommended way or a good idea to talk to the vendor of the tool if you can actually connect the data flow and start and end points in the Java and JavaScript world so that all the different checks that your tool vendor provides are also working across the language barrier from the native to the JavaScript HTML5 world. If you are mainly using dynamic analysis, like for example penetration testing, I don't think there are so many automated dynamic application security testing tools available that work on mobile applications. Then include in your penetration checks for checking the security of those cross-language calls. Like think about that a mobile application that shows you a web interface suddenly can have a SQL injection vulnerability locally, not only towards the server side, but really local towards, for example, a SQLite implementation being provided on the native part. Also, check for plugins in your applications that might only be shipping the native part because the developer thought that removing the JavaScript part of a plugin that provides the JavaScript interfaces already is sufficient for disabling a plugin. That's actually not true. If you're assuming that your JavaScript part could have a cross-site scripting vulnerability or some other vulnerability where an attacker can inject JavaScript, then of course an attacker can also inject the missing parts for accessing the Java interfaces exposed by a plugin. So if you want to remove plugins, remove both sides. And in some cases, you might even want to customize plugin in terms of providing, for example, a read-only access plugin to the calendar of the device or the address book of the device. And I told it already a couple of times, if you're doing a manual analysis of your checks or even automatically before you ship APK files to customers, check that the debug mode is disabled because it disables all the SSL checks. So, final conclusion, hybrid mobile apps are getting more popular, at least Gartner and other research institutes are telling us that this is the fact. I'm at least seeing that they are recommended by enterprise vendors and by software developers that need to provide additional features for existing products on mobile apps that should be rolled out simultaneously to multiple platforms, whereas companies that are really focusing on mobile development often prefer native apps because they might provide a better or richer user experience that is adapted to those platforms. Where I'm seeing an increased use of mobile apps is outside the traditional mobile device business. So for example, web kiosks or smart TVs. Again, they're adaptable, mobile websites already existing, easily integratable. It seems to reduce the development costs. And as already motivated, if you are going into the business of developing secure hybrid mobile apps, think about that you need to have the combined knowledge of secure web development, secure native development, secure mobile development, and the security features of the hybrid platform that you are using. With that, I'm happy to answer questions. Thanks a lot. Not in.
Yeah, so we haven't checked that library in particular, but we noticed that many developers, I guess when they start their Cordova app, they just use their familiar JavaScript libraries. And no.
I mean, it's not a contradiction. Cordova provides the core bare metal solution that JavaScript applications can access native device features, and then you want to have some rich JavaScript development experience, and then you're using something like AngularJS or some of the more mobile-specific variants. So, but we haven't done statistics on that. Any other? Yeah. Yeah. Yeah, if you're packaging, one way of using Cordova is, so to speak, to package a mobile website as an application so that the user has the experience of a mobile app, but in reality, the application is actually only a very thin layer towards a mobile website. And then, of course, people are penetration testing the mobile website. And the additional security problems introduced by Cordova are rather small. If you're not using Cordova for accessing device features, but only as kind of a lightweight way of shipping a mobile web browser that you get an icon on the desktop and a couple of other app-specific features, you're covering already quite a lot of the potential security problems by that approach, yes. I don't see any raised hands anymore, but...
Yeah.
Do you see apps being obfuscated in a way of Cordova apps being thrown out on Android?
We've seen obfuscated apps. I don't have any statistics how many percent of the apps were obfuscated. Informal gut feeling would be not significant more or less than for non-native apps.